In this video, we'll see about the math object of JavaScript. Math is a built-in object used to perform mathematical operations on numbers. It has properties and methods for mathematical constants and functions. It is not a function and it need not be created before using it. Next, we'll see about the properties and methods of this object. Math properties. The first property is capital E, which returns the Euler's number. As you can see in the example, first line document.title Euler's number with close the quotes plus math.capital E. Math M should be in capitals, and always when you use E, capital E, you have to specify it along with math. The second property is ln2, which returns the natural logarithm of 2, and its approximate value is given in the that is 6.693. You can see the same in the example, and its corresponding output also you can see. The second output displays ln2's result 0.693 and so many digits. And ln10, that is, it returns the natural logarithm of 10, which also represents a constant 2.302, etc. And the next property is log2e, which returns the base 2 logarithm of e, and it is approximately 1.442. You can see all these four properties depicted using the example, and the corresponding outputs also you can see. Okay. Next property is log10e, which returns the base 10 logarithm of e. Pi, next one, pi, which returns the approximate value of pi, which we usually use in mathematical calculations, that is 3.14159, etc. And then next is sqrt1 underscore 2, which returns the square root of half, and square root 2, sqrt2 will return the square root of 2, that is approximately 1.414. All these properties have been done using the examples, and you can see the corresponding outputs also. Next is about the methods of math object. First method is ABS. ABS returns the absolute value of a number. That is, absolute value here means the positive value of the number. As you can see in the example, the first line, that is document.title absolute value plus math.abs of any negative value when given will display in the output. You can see the first line absolute value of minus 8.4 is 8.4, that is without the minus sign. Next method is CBRT, which is it returns the cube root of a number, and you can see in the example for the same also cube root of 27 is given as in the output 3. Next is SQRT, which returns the square root of a number, and you can see the same in the example and its output. Trunc returns the integer part of a number by removing any fractional digits. That is, it will remove the fractional part and will specify the output of minus 8.4 as minus 8. Next is EXP method, which returns the e power x value, where x is the argument given and e is a Euler's number, and the same has been done in the example. and its corresponding output also you can see in the output section. Log x returns the natural logarithm base e of a number, and max of xy comma dot which means etc. You can give here any number of arguments, so there is no limit on the number of arguments. It will return the highest valued number in the list of numbers. As you can see in the example, I have used here 6 numbers in the max, out of which it will be displaying the highest value, that is math.max of 12, 3, 4, 56, 7 and 5. In the output section you can see the maximum value is 56. Similarly, you can do it for min also. It also has no limit on the number of arguments, and it returns the lowest value number in the list of numbers, and you can see the output also. Next is POW, that is which represents the power, that is it returns x power y, that is you have to give here two arguments x and y, and it will do the power of y to the power of x. Okay. Next method is sign of x. It returns the sign of a number, but the value of x here should be given in radians instead of angles. Next is cos of x, which also returns the cosine of the specified angle. The angle must be specified in radians here. A tan of x also, x should be given in radians, and it returns the tangent of a number. A cos returns the arc cosine of a number, that is the given number x should be between -1 and 1, and it will return a value between 0 and pi. A sine of x returns the arc sine of a number. Again here x should be between -1 and 1, and it will return a value between minus pi by 2 and pi by 2. Next one is a tan of x. It returns the arc tangent of a number, and it returns a value between minus pi by 2 and pi by 2, which is similar to that of a sine. You can see the examples for the same: sine, cosine, arc tangent, tangent, arc sine, cosine and arc tangent, and the corresponding outputs also you can see. And the sine, a math dot sine, I have used here math dot pi, that is in order to convert the angle into radians you have to do the formula, that is pi by 180 into x, that is the angle. So here instead of using the 3.14 as the constant, here I have used here the property of math object, which is math dot pi slash 180 into, this is the angle I am going to use, 90 degree. So that has been converted into radians, and the result you can see sine value is printed as 1. Similarly do for cos and tan also. Cos is angle given is 0, and in the case of tan the angle given is 45, and in the case of a sine, a cos and a tan, the instead of the angles we give here the values between -1 and 1. So here I have used 0.5 for a sine and a cos. There is no such limitation on a tan, so I have used here 2. The corresponding outputs also you can see in the output section. Next is floor. Floor returns the next integer less than or equal to a given number, that is it rounds down to the next integer. Okay, it always rounds down. Ceil returns the integer greater than or equal to a given number. It always rounds up the given number. Round x returns the value of a number. rounded to the nearest integer, and random returns a random number between 0 and 1, that is including 0 but not including 1, that is it excludes 1. You can see examples for this. Floor, math.floor of 3.4. Since I said in the previous slide that floor always rounds down, so 3.5 is rounded down to the integer closest to it, that is 3. Math.floor of 3.6 also will be rounded down to 3. It always rounds down. And math.ceil will round up. So 3.4 is rounded up to 4, as you can see in the output, and 3.6 also is rounded up to 4. Whereas math.round will round the to the next integer based on the uh, fractional section. If it is 0.5 and above, it will be rounded to the next integer, otherwise it will be rounded to the same integer. Okay, that is 3.4, since it is below 0.5, that is since it is below 3.5, it will be rounded to 3. And in the next example, math dot round of 3.6, since this is greater than 3.5, it will be rounded to 4. Next is random number. Random number generates a number randomly between the values 0 and 1. That is 0 is included for this case. That is, in the random number it may generate the 0 as a output in some cases, but it never displays 1 as the output, since within this range 0 to 1, 1 is not included. Okay, it will be randomly generating any number. This time it is printing 0.4. Next time it may be giving a different output. Okay, each time when you run this program, it will be generating a different value for different number. That's all about the properties and methods of math object. Thank you.